Okay, it's time. Terrace, would you like to get started?
Okay. So, welcome everybody. This is the first interim for the ANIMA working group in 2024. We set up this interim to run through a series of proposals for new work in ANIMA, which we think could fit the existing ANIMA charter, or if not, at least the spirit of the work to be done in ANIMA. And sorry if the time isn't fitting for everybody, but hopefully more people are able to easily watch the recording once it's online after the meeting. Wanted, before I go into detail, remind everybody that the IETF note well applies. I hope I don't have to go through it again in detail, but please exchange professionally and understand all the other details in here. So how do we relate the proposed work to the working group? Couple of proposals here are from people who haven't worked in ANIMA in before. So just a quick reminder. So we're an operational working group to standardize and experiment within network automation. That's what we've been built as a series of RFC in an infrastructure, and now bringing it closer to the application involves something we call autonomic service agents. Here is the list of the agenda items. I'm not going to go through all of them in detail here to save us time, but every presentation, please be less than 10 minutes, and discussions 5 minutes. We should also have good time on the side in the hallways or so during IETF 122 to follow up on the discussion, of course, on the mailing list as well. During the working group, we only have 1 hour for mostly reserved for existing work. So here is kind of a quick overview of how in ANIMA we're looking at in-network automation, and that is primarily embodied through autonomic service agents, which can be scripts running on routers or devices co-located with routers. When they run in routers, they're running on top of the infrastructure that we've provided, which is resolving all the things that typically today make automation in networks difficult. And that is, for one's connectivity, which we have the ACP for. It is the mutual trust, for which the protocol Brewski creates a certificate enrollment, and thus you can simply have, without additional new credentials, the Brewski certificates to run TLS or any other secure communication. And finally, and most importantly, GRASP as a unified protocol to enable very quickly to build new protocols between those distributed automation components. So,
Terrace, sorry to interrupt. Could you open your camera? Last year, there are several people who haven't seen you before.
Oh, sure. Of course.
Yeah.
Does this come up? All right, there we go.
Okay. Go ahead.
I don't want to walk through all this text in detail, but here are basically a couple of things that, simply building scripts or so on is something the operator can do, but what do we do as a standards organization? So the standardizable components, for example, primarily are the interactions that these agents have. It could as well be their procedures, but so here is basically that possible list of things we can standardize. And so it would be, Sheng, I, and other ANIMA long-timers that be looking at the proposals being made from the perspective, if so, which of these possible standardization aspects could apply to the proposals made. So in summary, the work items possible for ANIMA are extension modifications to those extensions that we have, but then primarily these autonomic service agents, and their interactions. And ultimately, being an ops working group, it is even more important than in others to see that we do have specifications that can be implemented, but operator makes sense for them. And so proof of concepts for any of the work would be really good to be able to understand how that would work, and describing such minimum viable implementations is typically one of the biggest challenge for more architecturally driven proposals, and it's always a very good thing to get done very early on to vet the work. So yeah, with that being said, I'd like to get over to the presentations. So let me see who was the first one here. You've seen the invitation with the note page, so would be lovely if each one you can chime in with collaborative editing of the notes. I'll start with that as well. Who's Leo? Is that you for the first presentation?
Yes.
Okay. Do you want to share the slides yourself, or do you want Sheng or I to share the slides for you?
Yeah, let me try to share by myself.
That would be lovely.
Okay. Thank you. Is the audio good on my side?
Audio is good, yes.
Okay, thanks.
No, Terrace, I still saw your slides. Yeah, I haven't seen these yet.
Yeah, I'm figuring out the right button.
Take your time, but you use the time within your 10 minutes.
Oh, it's so embarrassing. I just couldn't find the.
You have
the
button just beside the camera button. Share screen. The third one.
Oh, yeah. Yeah, can you see that?
I saw the indication, but haven't seen the slides yet.
Can you try again?
Yeah, I think I might need some improvement from you.
Yeah, I granted. Yeah, you need the grant from chair. Yes.
No grant request popped up, so strange.
Yeah.
But it's good.
It's some new function.
Can you see the slide?
Yeah.
There is a slide now.
Yeah. Go ahead.
Okay. Sorry for the. Okay, so the first topic is regarding to autonomic distributed troubleshooting. And as we know that in traditional troubleshooting, basically there are three categories. The number one is that simply the administrator just log into a specific device to make check on details by command line, one device by one device. And this is very, very time consuming and labor consuming. The second one is that we can utilize a controller or a centralized network management system to collect all the data among the devices and to do some data analysis. Sometimes, especially for the modern system, usually artificial intelligence is employed to do the smart analysis. But this kind of approach requires some bandwidth and very high cost of computational resource in the central system. The third one is that we all know that some protocol, especially routing-related protocols, they already include some distributed mechanism to notify some errors to some alarms within the protocol itself. So basically, our thinking is that why not to use the platform of ANIMA, that we can generalize the third approach so that we don't need to implement specific functions in each protocol, but instead we can collect all the functions we need to integrate them into one platform which is ANIMA's platform. Yeah. That's the basic idea. So there are some use cases. We do some analysis. Sorry. There are some use cases could be done by this approach. The first category is routing related. For example, in a BGP system, there might be some oscillation or we call it route flapping happen. And it's not difficult to observe route flapping is happening, but the real challenging thing is that how to identify the flapping source, because most of the time the whole routing domain is under flapping because of maybe only one router, that there are some routes appears and disappears very frequently in one router, so that it will cause all the routing system to enter an oscillation. So maybe we can randomly choose one of the routers, and the administrators can log into the router to active the relevant function that this one router will send a message to the next hop to ask, okay, so are you the source of the flapping? If not, that router will pass by the message hop by hop. So finally, the message could pass to the real source, and that source can reply an upstream to router for the information. Because for a single router, it is also not very difficult to analyze, to check by themselves whether there are some routes disappear very frequently. So they can do self-diagnose easily. So by utilizing the distributed message among the routers, so we can easily identify the oscillation source. And the second is in a MPLS path setup. There are sometimes there are some failures. Either it's the link failure, or maybe some configuration failure. It is a similar logic that if the router on the MPLS path, they can directly utilizing the signaling protocol to notify why currently the router cannot create the path and pass the information to the upstream. It's also very easy for the administrators to locate the root cause. So it's basically the same logic, same method to fully utilize the devices. They can do some operations hop by hop within a very specific protocol domain. That costs so much less resource comparing than the centralized approach. So I won't iterate on all the use cases. It's basically the same method. So another category other than routing related is some general troubleshooting. For example, there are some management protocols such as SNMP, netconf. Sometimes the protocol itself might fail. And when it fails, it will be very difficult for the administrators to log into the device. So if we can utilize the signaling protocol, then there just could be some out of band another channel to provide some of the opportunity. For example, the administrator can log into a neighbor device, and that neighbor device send the signaling to the device that the management protocol fails, so that the system can reply with some reason code or maybe some log for the administrators to easily fetch up what is going on there. And yeah, so basically the routing related troubleshooting and some general troubleshooting, it's the same method to use a signaling protocol runs between devices to easily carry on some OM information. So how ANIMA fits in here? It's obvious that we already talked about the signaling protocol running between devices. So we can just use GRASP to do the task. So in this case, the GRASP protocol could be considered as an independent troubleshooting tool, other than the protocol's functions that are under troubleshooting. So with this approach, it is okay that, for example, the BGP has some failure. The protocol might already down, but with the GRASP still alive, we can still get some information. That's a value of independent tool. And also, if we rely on too much on the protocol itself, maybe there are some unnecessary traffic, unnecessary computational load that can slow down the performance of the protocol, the routing, especially the routing protocol itself. The other benefit is that as we introduced at the very beginning, there's already some protocols integrated some troubleshooting function, but it's protocol by protocol, it's one by one. It's much easier to integrate, let's say, 10 functions into one protocol than extending 10 protocols. Yeah, it's quite obvious. So there's also some other benefits. For example, less bandwidth, CPU cost, and we don't need to rely on a centralized server, etc. Yeah, I will iterate one by one. Okay, so here's some very preliminary function requirements for the signaling protocol, which is GRASP. We make it from different dimensions. For example, we need to define some new options to carry on the troubleshooting information case by case. Maybe one possible way that for all the use cases listed above, there are maybe 7, 8 use cases. We can define 7, 8 new options one by one. And we can pretty much reuse the already defined, well-defined grasp, message, and interaction process, because as we briefly discussed, um, the logic is actually quite simple to do the troubleshooting between devices. The current grasp interaction process should be more than enough to fill the task. And since considering the protocols running directly within the network devices, so we needed to be as much lightweight as possible to minimize the resource consumption. And for transport consideration, maybe UDP is a better choice, and it's lightweight and it's more efficient. And for security, we are thinking maybe can decouple with ACP, which means we don't rely on the ACP to be the security protection. We can either integrate some security transport. In the case of UDP, maybe DTLS, and maybe also some a security extension within Grasp to make the payload more secure. But that's some details need to be analyzed for later. Okay, so that's the basic idea of autonomic distributed troubleshooting. So comments are welcome, and we also welcome participants to join in the new work. Okay, that's all. Thank you.
Yeah, thank you very much,
Thank you, Bin.
I think it would be great to detail, any of the, pick one of the examples that you mentioned for, let's say, one of the routing protocols that's typically always of interest, and really detail the outline of what that, agent for that protocol would need to do, like, what particular state on the node it would have to track, for example, by what mean it would discover a problem, and then maybe, talk to that agent talking to the peers agent to see that state, and then ultimately, what resolution or alerting could be done based on, the observed, undesirable change in state, right? So that level and getting to a proof of concept for that would, I think, be exactly, trying to bring this closer to the operators, and talk to operators at 122 to see what type of local agent based observation of the protocol would give them the most value, right? So that's the clarifications that would be great to move this further.
Yeah. Thanks for the comment. Yeah, we definitely need to make more details. So today's presentation is more about a brainstorm to show up the ideas to make attention.
But really, it's just try to do that just for a single example, because it's always easy with the broad applicability to get lost between a lot of things that are being just incrementally, but never getting to a point to be able to show a single one, right? So that's I think more important.
Yeah, agree.
Hi, Bin. I have three comments here. The first one is back into your page 4. You list a lot of routing. Yeah, page 4. Yeah. In your title, you write down it's routing related. But more important, you actually need to clarify it's routing related faults or issues, but you are trying to use the operational or management mechanism to solve this issue. That's why it's based in the ANIMA working group rather than to extend any current routing protocols to solve your issue. Routing protocol is
Sure.
yeah. And on your page 7, the table. Yeah. You say here you would like to have a lightweight, lightweight implementation. So for your information, we are already working on lightweight grasp protocols, which would also based on the CROP implementation, CROP protocol, which also lightweight and matured. So that's something you can use rather than say standard grasp protocol we have now. We're already working on the lightweight grasp for several IETF cycle, but it's still in the middle draft yet. We can promote that very soon. My last point is here. Last line, you write down not rely on ACP. Why not? Because for me, the ACP would be something, ideally isolated and stable channel you can use for your mechanism.
Yeah, from function perspective, ACP is quite a good tool, but there's some the bar is actually not low to implement ACP. Number one is we need to do a certain ACP is essentially a VPN. There are some routing protocol and the tunnels are binding together to form the VPN. That definitely needs some work on the device. The other the part is that it's IPv6 based. Sometimes, especially in small medium enterprises, IPv6 is not widely adopted. So there are some limitations in real practice. So maybe it's good to couple with a.
So that makes sense, but I still recommend you not rule out the possibility of using ACP. Make that optional.
Okay.
Okay. Thank you.
Okay. Yeah, thank you. And regarding to the lightweight grasp, yeah, we also noticed the new work. Let's see the details. Maybe we can do some collaboration on how to design the lightweight grasp more fit into real use cases. Thank you.
Yeah, sure. You are more than welcome.
I think we're running out of time.
Make a very good use of our efforts. Right. Thank you.
Thank you.
Okay. Thank you. Sorry for the bad opening of eating too much time. Sorry.
Hansing, are you there to take over the microphone?
Yes, can you hear me?
Yes, we can hear you fine. If you can click on, to the left of the hand to share your slides.
Okay. Can you see me? Professor Jiang, yesterday I have sent an email about my leader has told me this evening, please delete the case 2. It is not very suitable for the presentation. And the number 7 use case, the presenter is also me. Can I share number 7 use case?
Sure, yeah.
Sure.
Okay, I will share.
So you are actually saved as 10 minutes. Is that right?
Okay. Save 10 minutes. Can you see my screen?
Sure. Yeah.
Okay, I will introduce. This topic is about home broadband automatic installation and maintenance. Please see the first page. It reveals that the difference in the experience and skill levels of technicians directly affect their efficiency in solving problems. And the experienced technicians are able to locate and resolve issues more quickly, while novices require more time. Traditional home broadband installation and maintenance operations rely on human experience. The transmission of process information is not timely, and some real-time information queries, such as user packages, line and equipment transfer resources, and major network faults,
Hetty,
cut
you
over information.
on the first page. I don't know why.
Yes, I have introduced the first page.
Okay, that's fine.
Yes, it's first page.
And your
not
camera
wrong.
is black.
So can you
Oh,
try
my
to click
camera
on
is
full screen
black.
so that you go into presentation mode? Then it's easier to, especially the following slides, to read for the participants.
Yeah, I only see a small slide now.
Yeah, so you need to go full screen and then turn on presentation mode.
I have just turned on the full screen.
Yeah, you need to do presentation, share your screen after you've opened the presentation mode window. Otherwise, you continue to share the other window.
Oh, sorry to waste time. This is my first time to attend this
No worries.
IETF meeting.
Do you see it full screen? No, you also see.
Yes, I can see the full screen. The full
你用播
screen.
放模式，那个
No.
换播放，你没有播放，
Oh, okay.
放映或者
Can you see the full screen?
hold on a second.
It's probably one of those Windows PC
You,
issues
you
where
can also use the reading mode. 阅读模式也可以。
I mean, one of us can share the slides and then you can say, go ahead, if that's fine. That's easier for you.
In my side, this is the full page, but I don't know why. You see, it's different from me.
We can leave on it. Go ahead.
Okay, we'll go ahead. Okay.
No worries, go ahead.
Okay, this is the second page, background and brief introduction. And this table, can you see this table?
Yeah.
Okay, and it lists two cases, scenarios of broad brand installation and maintenance that only require manual assistance. Problem is as the five case, and the how to solve it's mainly rely on manual assistance. And now, and the case B is realize intelligent diagnosis and one-link repair of the new business faults through the combination of large network models, agents, and product diagnostic and repair capabilities. And the users can ask their problems, and the intelligent agent can, according to what the users ask, give the right answer. Like this. This is 10 step.
Sorry,
And
which slide are we now looking at? Is it should it be number 3? Because I'm seeing number 2 here.
Number three is
There was
here.
no table. Yeah, I didn't see a table. Yeah, now I see a table.
This table, pink one.
Yeah, now you're on page 3.
Or Professor Jiang, can you help me to present the PowerPoint?
Okay, stop your sharing, then tell us. Could you
Yeah.
share?
Okay, I will stop sharing.
Yeah.
Lots of mistakes.
No worries. That's
No
no,
worries.
this is Windows making life hard for everybody. That's always happening again.
Yeah, I believe that's it.
Yes, this tip. Yes. Can you
And then
see
just
the
say
next
next slide when we need to move to the next slide. Please go ahead.
Yes, next slide. This slide has introduced. Oh no, this is not newest one. This the.
If you want to skip something, simply say skip it, right? So, or does does your latest version of the slide have new material that isn't in the version that you sent us?
Yeah, this is not the newest one. I
Yeah,
have
but
sent the
is it
newest
missing
one yesterday.
information? Is it missing information?
Yes, missing lots of information.
Oh, okay. Well,
Hold on a second. Let me check. Terence, could you stop it? Then
sure.
I will try to use mine.
Professor Jiang, can you open up your mailbox? And yesterday.
Yeah.
And yesterday. Yes, this is the newest one. Thank you so much.
Yeah. So is
yes,
this
this
right
is table.
page? Yeah.
The pink one. Yeah, this has introduced. Yeah, you can see case B and the intelligent AI and the intelligent agent can, according to the what users asks, give them give him or give her the right answer. Next page, please. Next slide.
Sorry, cannot see the screen. It's hard to read.
Okay, so it seems.
Yes, this one.
Yes.
The importance of using the GRASP protocol for collaborative innovation lies in its ability to enhance installation and maintenance efficiency through the creation of self-service intelligent solution. You can see the four blue box. User can interact with the LLM. This is a large language model. And the large language model can communicate with the agent, and the agent can communicate with the AI provider. In summary, their aims to introduce 5 key innovative technologies is improving installation and maintenance efficiency, as well as the application of these technologies in practical scenarios and methods for collaborative innovation. Next page, please. Fifth page. Yes, you can see the process example. This page mainly introduces the functional models of the home broadband installation and maintenance. An intelligent agent with the primary functions of these models described as follows. I have just introduced the main models. An intelligent orchestration, you can see this model, intelligent orchestration in agent box. Automatically manage and schedule various commands and functional models in the system through preset rules and algorithms. And this automation feature can significantly improve the operational efficiency and response speed of the system. And API ability arrangement, you can see this one. It is an intelligent agent that obtains which business APIs should be called at a certain step based on the logic set by experts. And API scene information management. It is experts' function, writing, troubleshooting, and disposal logic. And the capability provider, this is like this is the right one, capability provider. You can see Docker's provincial company support system. That function is encapsulate and provide callable APIs. These APIs are some kind of capability, such as the balance checking API, which provides the ability to check whether the phone is in error or not, and how much balance it has. Professor Jiang, next page. And the 6th slide, you can see the right part. This is next steps. This next steps is the GISP protocol contains 9 types of information and how to matching the agent is you can see the picture. Step 1, step 2, from step 1 to step 5. I will introduce this detailed. Implied in step 1, when the system needs to query broadband accounts and installation addresses, it may first need to locate the relevant network devices or services through network discovery mechanisms, but this step was not explicitly mentioned in the scene description. And the discovery response message, this is the second step, used in step 1 as a response to network discovery requests. 3, 4, 5, 6 is negotiation request message, negotiation message, wait message, termination message. These message types are reflected in the home with status query. That is step 2. And the parameter configuration, a variant of step 3, which requires user information for parameter configuration API. The system may need to negotiate certain parameters with network devices to achieve optimal network performance or wait for user confirmation when configuring parameters. If parameter configuration involves the collaborative work of multiple network devices, the negotiation process may be more complex, requiring multiple iterations and waiting. And 7, 8 is synchronization request message, synchronization message. It is reflected in the state synchronization or configuration synchronization of network devices, but it is not explicitly mentioned in the given scenarios. However, it can be inferred that after remotely resetting the optical modem or remotely restarting the router, the system may need to ensure that the configuration and the status of all related devices are synchronized. And 9 is flooding message. Flooding message is commonly used for network discovery or information dissemination during the speed measurement process, that is step 4. It may be necessary to broadcast certain information to all devices in the network, such as speed measurements, results, or configure. Yes, this page is 6 slides. This step is similar to the flooding message in the GISP protocol. Oh, Professor Jiang, it is not 7 slides. I have introduced the 6 slides. Page
Sorry,
6.
I thought Go ahead.
Yes, I have introduced step 5 and the step 5 how to match the flooding message. The system may need to notify relevant maintenance personnel or the system about the issues of slow internet access through network broadcasting or multicast in order to carry out subsequent problem repairs. Next slide, please. And I have received some.
Can you shorten that out a little bit? Sorry, we're running a little bit late due to all the errors.
Okay, I will more fast.
No, we
sorry.
understand. We understand those benefits. That's why.
Okay, this benefits is limited flexibility and limited adaptability. You can see the two advantages. And the eighth slide. Next page, and optimization and innovations to the GISP protocol. This is what I found, what our team found. Optimize device discovery mechanism. You can see existing functionality, optimization points. Conversely, when the network condition poor or devices respond slowly, the timeout should be approximately extended to ensure that devices have sufficient time to respond to discovery requests. And the optimized device negotiation mechanism, GISP protocol supports request to negotiate and negotiate step functions for negotiation between devices. And the optimization points is support high concurrency negotiation through multi-threading or event loop mechanisms and dynamically adjust the negotiation process using negotiate wait. And the next page, please. And the multi-threading mechanism also enables small granular resource management and loading balancing, ensuring the smooth progress of the negotiation process. An event loop mechanism. The event loop mechanism is a non-blocking isochronism processing method suitable for scenarios with high concurrency and real-time requirements. In the GISP protocol, the event loop mechanism can be utilized to monitor and process negotiation requests, avoiding performance issues caused by traditional blocking calls. Through the event loop mechanism, asynchronous processing and rapid response to negotiation requests can be achieved, improving the system's overall performance and user experience. And this is what I have shared. Thanks for listening.
Thank you very much. Yeah, I think it would be best if we go on now with the next presentation so that we don't run late. And if we have time at the end, we can collect more questions for the different presentations. Sheng?
Sure. Yeah.
So
we can give our comments by email if we don't have time discuss it.
Yes, this is Feng Yang from China Mobile. Can you grant me the screen share?
Yeah, I already approve it. Just a minute. Just a second.
Okay, can you see my screen?
Yeah, so it's now.
So this is from Feng Yang from China Mobile, and people just talking a lot about the maintenance. I would like to tell some of the new services that ARN can make. Where see the next page. So how can I change to next slide?
Just the arrow keys typically?
Okay.
Or space
So
or return? Sorry.
Yeah. So the motivation is that we have already deployed the SRv6, but the SRv6 is not visible to the user. That because SRv6 is only running within the limited domain. However, the users are outside of this limited domain, and it is impossible for this user to run to avail the SRv6 service. So page 3. So our goal is to steering the user traffic to SR policy or network slice on demand, providing differentiated service to users. Current technologies such as queues and ACLs cannot meet such kind of requirement. So we want a kind of technology that is trustworthy, scalable, and simple to make the SRv6 service to be visible to the user. So here I just talk about some of the some of ARN, and later on I will talk some relation why ARN is relevant to ANIMA. So the primary use case of the ARN is to have the service in SR network and make them visible to user. In this diagram, user can access the network through any means such as PON, LTE, etc. And the service provider's backbone network operates SR or a slice, offering services that guarantee a low latency or low packet loss. When ARN is deployed between the user and the backbone network, as well as between the backbone and the content service providing picture, it can steer in both upstream and downstream traffic to the corresponding SR policy or slice, thereby providing differentiated services. So ARN can support both of the SRv6 and MPLS. We can mapping SR policy or slices into ARN ID, or put it simple, we can give an ID to the SR policy or the slice. ARN ID is a number carried in IPv6 packet associated with the control plane, BGP color, or IGP flex algorithm. And the flex algorithm is a method for the network slicing. ARN ID has two types, user and network. On the network side, the ID is generated during the network planning. During that time, we can assign an ARN ID to each SR policy or slice in the backbone network. In contrast, a user ARN ID represents the network services that's subscribed by the user, with each subscription have unique value. By correlating the user and the network ARN ID, we can make SR path services visible to the user. So the ARN ID ARN architecture just consists of multiple domains, from the user domain all the way to the content service provider domain. That here is just an example. Maybe that also can fit with a campus domain. In the user domain, there are user edge services, edge devices that classify traffic using ACL and label it with ARN ID. That ARN ID is we call it user ARID. On the network edge service, on the network edge devices in the metro area are configured with mapping table that translates user ARID to network ARIDs. So that ID will automatically associate with SR policy or slices in metro domain. So on the boundary of the between the metro and the backbone, the ARID is network ARID is carried all the way to the backbone domain, and it will be mapping to the SR policy or the slices in backbone domain, all the way to the CS content service domain. So that is the upstream traffic. The downstream traffic follows a similar behavior, just requiring the user edge devices of the content service provider to label the traffic with ARID, and the ARID will be mapping to the backbone domain. What has been done for the upstream traffic.
You have 3 minutes left.
That should be fine. Why it's relevant to grasp, because the negotiation of the ARID is very complex. So I will tell it later. This is some of the implementation of ARN, so we can just skip it because it's kind of the internal implementations. Regarding the cross-domain negotiation issue of the ARID mentioned earlier, I have an example. Suppose user subscriber subscribes to a connection service with a latency requirement of less than 17 milliseconds. There are multiple paths with different latencies between the metro and the backbone. Choosing the optimal latency path is not an easy task, because we cannot simply select the path with the lowest latency. Instead, we need to find a path whose latency requirements exactly fits the user's needs. This requires multiple rounds of negotiation. So coordination with a controller is one approach, but it can be very complex. First, the super controller is needed to coordinate the different controller in the metro and backbone. Second, the network device must report the latency information as such kind of things to the controller. Then that's the controller performs computations. When the network scale is really large, the kind of coordination become, I think, extremely complex. If the negotiation is can be processed by the network devices, it can simply simplify this unnecessary overheads. So that's we can use Grasp for such kind of multi-run negotiation. So so this example is easy to read, so I will not talk it more. So last page is that we have done some of the work, but because the cross-domain case is really complex, so we only have some intra-domain work has been done. So in the future, we will try to find a way to solve the cross-domain issues and see if we can have grasp to solve this issue. So thanks. That's all.
Yeah, thank you very much. So yeah, it's always the problem when you have a system with a lot of background, and we're just trying to get to the point of using, for example, the ANIMA framework for that. So hopefully we have some time to discuss that in follow-up, maybe during IETF 122. It seemed as if there wasn't only communication of the ID, but also negotiation of the properties associated with it, or the performance, parameters that are getting there. And I can see how that can be complex within a domain where you trying to use a grasp also for negotiation between the nodes within the domain, or only interdomain.
Yeah. Thank you.
No, sorry, that was a question. So were you thinking of using grasp also between the nodes within each of the domains, or only across the domain edges?
Because within the domain, the controller has already done all of things.
Okay.
The thing is also already in place today.
Okay, thank you. If there are, let's go on to the next.
This is Jing Zhao, and I want Chairman Jiang to help me play my slides.
Okay, so you want me to share with you for you? That's fine. Let me
Yes, thank you.
found it. So that's autonomic network congestion relief, right?
Yes.
Okay. Oops, sorry. I share something. Share another slides. That's it. Right? Can I say it?
Yes.
Okay, go ahead.
Good afternoon and evening, everyone. I'm Zhao Jing from China Unicom. It's an honor to participate in this working group online meeting. Next, I'd like to introduce automatic network congestion relief mechanism to you all. First, I will introduce. Next page, please. First, I will introduce the background of the mechanism. Nowadays, fiber optical failures happen frequently, leading to network congestion and becoming a common pain point for operators. These issues require specific personnel to conduct daily inspections of traffic and adjust configurations, which significantly increases the difficulty of network operation. We propose an automatic congestion reflex mechanism based on intelligent traffic analysis and autoregulation. In the event of congestion caused by fiber optic failures, it can respond intelligently and self-heal in real time, ensuring the stable operation of the network. Next page, please. Next page, yes. Next, I will introduce the implementation method of this mechanism. The second level mechanism is automated through the intelligent module of the device. Leveraging intelligent traffic analysis, it precisely calculates the volume of traffic requiring redistribution. Subsequently, it redirects the traffic to paired devices via inter-voice particle announcement and the automatic adjustment of routine parities. I will introduce the process of how the device automatically implements this mechanism in 5 steps. The first step is traffic modeling. The forwarding chip of the device performs real-time traffic sorting using full flow data and identifies the top N traffic flows. The intelligent component of the AI chip subscribes to the BGP route and employs intelligent flow recognition algorithms to perform AI-based traffic modeling, which provides the basis for traffic detection and regulation. The intelligent flow features statistics cover many dimensions, including flow rate, packet length, and the proportion of TCP/UDP traffic, and so on. Next page, please. And the second step is traffic monitoring. Through the extension of the BGP-LS protocol, the inter-domain link bandwidth and load changes are optioned by the voice in real time. When the link bandwidth exceeds the set congestion threshold, it is reported quickly. The interface statistics time is at the second level, and we utilize bandwidth to aggregate the inter-domain BGP EPE link bandwidth and bandwidth utilization rate. The format of the BGP utilized bandwidth TLV is shown in the picture. It reuses the maximum link bandwidth TLV type 1089 in FC 5305. Next page, please. And the third step is intelligent policy generation. When its utilization exceeds the predefined congestion threshold, the device launches intelligent module. The device intelligently calculates the level of traffic to be redistributed based on traffic analysis. The fourth step is policy propagation. Announce the automatic adjustment mechanism of routine priorities through the BGP RPD protocol. Automatically allocate the calculated traffic to lightly loaded plane. The end-to-end process is completed within seconds, leading the congestion to the original plane. It can precisely counter neighbors and passes without affecting the exiting routing policies in the current network. The fifth step is policy reversion. After the interrupted link recovers, the optimization policies will be withdrawn. Next page, please. And finally, let me introduce an example to better explain the process of the above-mentioned mechanism. Before the process, we need to establish topology mapping in network 1 between CL1 and CL2, as well as C1 and C2 in network 2. Clearly define the connection relationships. First, CL1 CL2 can complete the top N traffic modeling on the link in real time and automatically. Without any human intervention, they can accurately understand the traffic condition of the link. For example, the system can automatically monitor that the total bandwidth of the traffic channel between CL1 to C2, C1 and CL2 to C2 is 800 GB, and the current traffic on both paths is 600 GB. Next, if the CL1 device detects that 5 links between CL1 to C1 has failed, leaving only 3 links, the device can automatically determine that congestion will happen on the CL1 to C1 link. Then, as the primary adjustment device, the CL1 intelligent module can automatically generate optimization policies based on the established top-N traffic model and the real-time collection prefix information. After CL1 generated the traffic policies, it automatically sends them to C1. And when C1 received the policies, it lets the remote routers to adjust their routing paths. The device can intelligently identify and divert the two servers with the highest priority from the CL1 to C1 link to the CL2 to C2 to solve the congestion on the CL1 to C1 link. After the policy adjustment, the device automatically monitoring that the traffic on the CL1 to C1 link is reduced to 300 GB and the traffic on the CL2 to C2 link is increased to 800 GB. This automated policy propagation and traffic diversion process is highly efficient and current, improving the utilization efficiency of network resources and quickly solve the link congestion problems. When the failed link between CL1 to C1 are restored, the system automatically detects the change in the link status and withdraw the policies. That's all. Thank you for listening.
So my question here is, are you going to use the GRASP protocols to do the negotiation and the control activities? Is that right?
The question is valuable. We will take this aspect into consideration in the future.
Okay. Yeah. Teresa?
Yeah, do you have an example of kind of the policy that you would apply before and after a failure? I mean, what's the policy? How would they differ?
You mean the
Yeah, you've been saying that upon detection of a failure, you would apply and signal to the other nodes a change in policy. Could you give an example of how that policy would look like and how it would be different from the no failure condition?
Yes, when the intelligent module fails, the system will trigger a fault alarm to notify the operation personnel to handle it in time limit.
Sorry, I didn't catch that.
The intelligent mode when the intelligent module fails, the device will trigger a fault alarm to notify the operation personnel to handle it in timely.
No, but I was asking about the policy. What is the policy that you would apply? It's not I mean, right?
Yeah, I think this kind of policy could be some algorithm configured on the devices, which has intelligence enough to do the negotiation and deciding by themselves.
Yeah, I would love to understand if Ying has an example of such a policy.
Yeah. So next time she should make more detailed example and how it could work together with those negotiation process and how to use the GRASP messages to do so. Right.
Yeah, and I would recommend, if you are not subscribed to the ANIMA mailing list, subscribe to the mailing list, then we can take it to the mailing list. If you're in IETF 122, we can also sit down and discuss that. If not, I think it would be best to continue the discussion on the mailing list, and I think we can give you some suggestion if you're unsure.
Yes, I'm already subscribed the mailing list, and we have prepared a draft plan to submit in the working group. And after I submit the draft, you can give us some comment.
Yep.
Yeah.
All right. I think we're running short on time, so let's go to the next presentation.
Yes, thank you.
Sorry, let me find. Okay.
Yeah, here we are.
Yeah.
Go ahead.
Okay. Well, this is Julian from CNIC, and this use case is the mobility management and capability negotiation. And sorry. Seems I cannot control the slide.
How about the arrows? How about space? How about return? Try all the usual suspect keys.
I want to let it, this one, okay. And it's okay?
Yeah. Oh, yeah, okay. Yes.
Okay, you know, in the past 30 years, IETF has standardized many mobility management protocols based on IPv4 and IPv6 for different scenarios, including some performance extensions and some function enhancement. These protocols can be classified into two types: the host-based protocols, which require the active involvement of the mobile device in order to accomplish the mobility management, and the network-based ones that require the non or minimal involvement of the mobile device in order to accomplish the mobility management. In this figure, we show the two categories of the mobility management protocols. For the network-based ones, the proxy mobile IPv6 is a very important basis, and many extensions were standardized based on the proxy mobile IPv6 protocol. On the other hand, based on the mobile IPv6, which is the basis for the host-based mobility management protocol, many extensions also have been standardized for the performance improvement and function enhancement. The problem is that when a mobile device access to the network or handover between different access networks, which protocol should be used, and how to negotiate this protocol. For example, because the network may have different supported protocol, and also the host may also support different protocol. Then they need to negotiate and select a suitable one. Then we think the first question is what kind of principles should be followed. For example, The first one is to follow the network ability. The second one is to follow the host performance. And the third one is to support the functional extensions, such as the network mobility. And the fourth one is to support the performance enhancement. For example, the fast handover mobility management. But in default, the network-based scheme should be used if it can be supported, because it has a lower cost for the mobile node. If the host prefers the host-based protocol, a negotiation is exacted to hand over from the network-based protocol to the host-based protocol. And after the initial attachment, a profile should be generated in the management store to record the selected or preferred protocol of this host. And when the handover happens, the network will check the selected or preferred protocol. But the network also needs to notify the host if the selected protocol cannot be supported. And I have an example here. For example, the host has a network-based support, and the network also has a network support. If the host can only support the proxy mobile IPv6, while the network is also only support the proxy mobile IPv6, then it's good. The proxy mobile IPv6 should be used. But if the host can only support the proxy mobile IPv6, but the network has more extensions, more functions to support some extensions of the proxy mobile IPv6, then the extension of proxy mobile IPv6 can be used if the mobile node should not be involvement or required to have required no extra functions. Otherwise, the basic proxy mobile IPv6 is used. And if the host can support some extensions of the proxy mobile IPv6, but the network can only support the basic proxy mobile IPv6. The basic proxy mobile IPv6 can be used, should be used. And in the fourth case, if the host and the network can both support some extensions of the proxy mobile IPv6. If the supported protocol for the extension protocol is the same, it can be used. Otherwise, the basic proxy mobile IPv6 can only be used. That is a case for the protocol selection. So we think maybe in the ANIMA working group, the GRASP protocol or other protocols can be used in this scenario to support the mobility capability notification and the protocol negotiation when the mobile node access a new network or hand over to a new network. Otherwise, on the other hand, parameter setting for the optimized mobility management can be notified and negotiate between the host and between the node using the GRASP and other protocols. And that's all. Thank you.
It's great. Yeah, so I think we need to see more concrete and detailed example. How to make this negotiation process, and also how complicated the whole mechanism would be. Whether we need to break down into several use cases, or it's simple enough to do it in one single draft, right?
Okay.
Yeah, have you tried to build any prototypes or proof of concept, any any practical work on this beyond trying to specify it?
Actually, we have designed some negotiation protocol based on the ICMP-v6, and we also drafted it in the previous versions of the draft, but we did not do some implementation and test of that.
So have you tried to map this into Grasp?
Yeah.
Yeah, so that would be interesting to see in terms of, you know, what information elements you intend to signal between nodes. That already gives some better understanding of you know, what the negotiation would involve. So that would be lovely to see.
Okay. We think that Grasp has more general function for this kind of scenario between the negotiation between the network and the host, and I think it is very suitable for the mobility management when the node access or handover in the network. Yeah, but
I mean,
yes,
there are a couple of you know, differences between ICMP and Grasp, right? So it would be good to understand what communication patterns you have if you only need point-to-point communication, or also some of the flooding or discovery, right? So those are, I think, the details that would be good to understand.
Yeah, I understand.
Okay, any more questions?
Hello, Zhiwei. It's Ben speaking. You mentioned that the host communicate with the network. Is it only specific to the handover procedure, or it's something in general, not only the handover procedure involved in the host network communication?
I think there are two cases for this kind of negotiation. When the mobile node bootstrap and access to the new network, it may need to notify the network about its capability and preference of the mobility management protocol, and the network also needs to notify the node about this. And in the second case, it happened during the handover because the new network may support the different protocol for the previous one. So they need to negotiate again to select a suitable one protocol to continue the mobility management.
Okay, thank you. So it's mostly regarding to the mobility management. Do you see the potential that maybe the host can collaborate with the network for some service aspect, maybe to have better transport of the data, or maybe some other things?
Yeah, it may benefit the selection if the host can collect more information from the network to help it to decide which one is the best one.
Okay, thank you.
Thank you.
I think, Leo, you're up again. Okay, some time check. We have half an hour left, and I think we still have 3 presentations. No,
no, we have only 2.
We have only 2, right. So what did I do here? Yeah, okay, sorry, I forgot to delete number 7. Good, so then...
Bing, we cannot hear you. No, Bing, we can't hear you. You mute yourself. Bing? You?
We still can't hear you. No, you're talking, and wait a second.
We can't hear you.
So, okay.
Oops. I kick him out.
Yeah, let's give him 1 minute. Otherwise, we'll switch presentations.
Yeah, so maybe we give
This
him.
is a live event, nothing pre-recorded. We're sorry.
Wait a half minute, then we may move to Peter earlier.
I pinged him. He should join no time.
Yep.
Okay. Yeah.
Thank you, Peter.
Yeah, show him back.
All right. Should we move to Peter?
Still cannot hear.
Can you hear me now?
Okay.
Yeah.
We can hear you.
Yeah.
All right.
Welcome back.
Made it back in time before we would have switched your slot. All right.
Sorry. I just used the Bluetooth. So wireless is still not very reliable than a wire.
Okay, go ahead. Make your presentation.
Okay. So I assume you missed everything.
Yep. Start from the beginning. I'm passing you slide control, so hopefully you can control the slides. Can you check?
Okay. So this is a very simple description of the scenario. As you can see in the figure, there's a typical campus network. There are several layers from the bottom, the access point to the access and aggregation switches and to the gateway. And there are numerous kinds of hosts, including PC, laptops, cameras, etc. So basically, the requirement is that after all the hardware, the network equipments are installed, for administrators, they want the whole network just to be bootstrapped automatically. Ideally without any manual configuration. So that's a basic goal. But for such kind of campus network, there's always some limitations or specific features of these kind of networks. For example, especially for the small and medium campus networks, they just use Ethernet for routing. They don't want to configure any L3 routing to do the area division, to plan in the prefix, etc. They just want to plug and play. And so Ethernet is always a good choice, especially for small medium networks. And the other is that for some reasons, maybe the limitation of budget or maybe they just want to avoid to learning some new sophisticated controller system. They just don't deploy controller or even some centralized network management system. So that's another limitation. And the third one is, of course, for some small devices, they are very resource constrained, either for the CPU RAM or for the TCAM for forwarding plane. So that's some basic idea of the scenario. So for ANIMA, we also want to utilize the grasp to it's like a glue when because usually there are several steps need to do together and for bootstrapping. For example, as listed, the devices they need to be discovered for each other. There might be some possible rules as I briefly described in the last slide. There's several kind of rules, the access point, the switch gateway, etc. And there's a new concept. We call it a local controller. This is something that because for the scenario that they don't have a centralized management system, but actually they need some similar thing comparing to a network management system, but just deployed and on a gateway. Yeah, that's something we call it a local controller. So after the discovery of the devices, the layer 2 topology could be collected so that in a local controller, the administrator can see the whole network and the topology. And yeah, before that, of course, that there might be multiple local controller. Normally, the local controller need much more resources than small switches. So in practice, it is in the gateway, which is the relatively high performance and also high precision that can cover all the campus network. So if there are multiple gateways, there need to be some self-selection and false switching mechanism for the local controller. And of course, there's it's a requirement that the configurations regarding to some basic network connectivity, especially in the L2 case, the VLAN configurations need to be done automatically, which is the next use case we'll introduce. Whoops. Okay, for the VLAN auto configuration, it's the same network after bootstrapping. All the different kinds of nodes, they might need to circle in a specific VLAN. So the basic assumption that the administrator, they can log into the local controller, which in this case is the gateway at the top. And there might be some web-based interface. The administrators can see the whole topology, can see all the network devices or even all the hosts. And then maybe the administrator can select some some interface, some access point, or access switches to binding them into one VLAN. This operation is manually, but after that, the local controller can act as a kind of network management system to compile all the configurations and deliver these configurations into the relevant network devices through the GRASP protocol, rather than traditionally the NetConf or SNMP management protocol. So it's we can consider it as kind of semi-automate, because at the very beginning there need to be some manual configuration, but after that it is fully automatic, and it is also could be considered as semi distributed, because the logically is actually the same with a centralized approach, but the only difference is that the controller is co-located in the network device, and the protocol is the ANIMA's GRASP protocol. Yeah. Okay, so it's a similar some basic analysis of the requirement to the GRASP. We also need to do some new definition on options regarding to the bootstrapping configuration, bootstrapping functions, and VLAN configurations. And the message and interaction mechanism could be totally reused. And maybe we also need some extension capabilities as defined in another draft. It's called this GRASP distribution. And yeah, it's similar consideration because it's running in the devices, so it should be as lightweight as much as possible. And the UDP is preferred, and also we want to decouple with ACP. ACP should be optional. Okay, that's pretty much the use case. Thank you.
Kailash, we cannot hear you this time.
Oh, sorry, I misused the button. There are a bunch of proprietary protocols from different vendors to signal VLAN information, right? So Cisco VTP, MVRP, from the IEEE actually, there is GVRP, there is Juniper's protocol, which I don't know the name of. Extreme Network has one, right? So it would be really good to have some understanding how, you know, the GRASP-based solution and or the use case goals would differ from those protocols, or even if, you know, there is a need for an IETF based protocol that does exactly the same thing as all this variety of vendor specific or, you know, IEEE protocols.
Yeah, I think it's pretty much the latter one. Currently, we don't think there need to be more sophisticated features or functions than the current commercial ones, but we need a standardized way to do the similar actions among different vendors. Yeah, we'll do some
the main comparison point would be GVRP from IEEE, where maybe the main argument against that is that it's from, I don't even know if it's from the last millennium or how old it is or so, but it would certainly come up in the discussion as to why the IETF would need to do something.
Sure. Yeah. Maybe we can also incorporate some new features because as I briefly introduced, the currently we assume the VLAN configuration was manually triggered, but maybe we can also have some policy based on the type of the host to pre-make some policy there, and according to the type information, it can be automatically.
Right. But don't call it add some features, but call it solving additional deployment requirements, right? So whether that requires new feature or not is a different question. But if there are requirements that go beyond that what existing protocols have solved, then that's a very clear distinction.
Okay, thanks.
Okay. Okay. Are we up to Peter?
Do I get a question? No?
Oh,
Yeah.
sorry. Please.
So I'm really kind of confused about some of the assumptions here. In the slide 2, it says there's no controller and they don't want to deploy it. And then you say there's going to be a logical virtual controller. It's still required and we're going to put intents in it and stuff. So I don't really understand. Is there a controller or no?
Okay, so there's no controller as sorry, let me render it in another way. There's no dedicated controller system deployed because in many cases it's too expensive, it's too human
so there's
labor
a virtual
cost.
Appliance.
Yeah, it's a virtual one.
So why is that different?
Yeah, logically, it's essentially the same thing, but as long as the controller can integrate it into the device, it could be very convenient for the users to get in touch with it, and the budget is so much lower than deploying a dedicated controller system.
I don't think it's the price of the hardware that's the problem. I mean, there's lots and lots of systems deployed as virtual machines going back 20 years. I've never physically deployed a Junos, for instance, controller as a physical machine. It's always been a VM. So I mean, that's what experience I have. So I don't understand the assumptions or the price, the economic argument you're making here. I mean, the price of the controller is not the hardware. The price of the controller is the maintenance agreement and the training and all that other stuff. And that's why they don't want a controller. They just want magic, right? So
no, Michael, the established operational model is simply that, in these type of networks where you need to go to one or two devices and configure them to be, the designated root of your spanning tree environment, that you would also configure the policy for the different VLANs on them, and then the proprietary protocol would be used to disseminate that policy. That's
right.
the established.
I understand now. I understand now. So every switch can be a controller, is what you're telling me, and it's a grasp level thing.
Yep.
All right, that's interesting.
Okay, that'll be my turn. I think I asked for screen share permissions.
Approved. Wait a second.
Ooh, okay. All right. So I will be as concise as possible to make sure that the meeting does not extend its time. So this is our NASA use case for ANIMA. So NASA is an initiative that we have been pushing forward for a year. and there are certain cases, currently our technical solution is simple, it's minimum usable, but centralized, it's not very scalable. So there are certain things that we believe that ANIMA, it could be an ANIMA use case for wider area, deployments and autonomic deployments, and to make it more scalable. So I will be very quick about what is NASR. So we kind of believe that due to some policy or technical reasons, our clients are, right now not so satisfied of their traffic only being encrypted and signed. So they want more like a physical, security. For example, like some policy will require that the data only transit inside of one country and cannot go to another country unauthorized. So for example, in this case, the Switzerland, if they want to make a internal domestic transaction, it cannot pass the obvious path through France, which is shortest. But for compliance reasons, it must go the very curvy one above to make sure it stays in Switzerland. And also there might be other requirements. For example, like the Switzerland clients might be very picky of what kind of cryptographic algorithm they're trying to use, or they want to make sure that their routers and switches are all pass integrity checks and secure boots. They want to make sure their young data is pass provenance checks. Their patch is latest, so on and so forth. So they want to choose only these trusted devices. So currently, like the NASR goal is to want to provide this kind of framework that help the operator to provide this kind of service, this kind of enhanced service, so to speak. So there might be a 3-step process. So number one is to pick the devices that falls into the client requirements. And number two is to orchestrate a path. So right now the problem is the path is centralized, computed. So it's a path that's computed by a controller. It's used like the easiest way to do it is segment routing, and then the verification will go on and on for verification purposes. So what we think that might be possible requirements for ANIMA is that we want to make sure this process is not so bottlenecked to the controller, because like the controller must handle the updates of the network devices. It must also evaluate the security, like the configurations, exposure, and everything. It has to set up and compute this south routing path. So they are all bottlenecks. Okay, so we might think that although I'm not a super ANIMA expert, that we might need some advice and directions from the chairs and also experts. But we think that there are some cases, for example, when the devices are past some trusted evaluation or some kind of ongoing deployment, and then there should be like auto discovery procedure instead of only like one-to-one to the controller. So the attestation results or the evidences for remote attestation procedures could be automatically passed to the controller or maybe to the peer network elements. For example, right now the trust evaluation is done only on the controller, but we think maybe this should be like distributed trust evaluation or security evaluation. So there could be like a part or a module that not only helps this device myself to boot securely, but also we can help to evaluate other network elements, such that some kind of distributed trust evaluation and some distributed agreement could be done in this process. And then there could be like a trusted path setup, or so to speak. So when this kind of device is secure, is deployed, it has some control plane, communication with other peers, it should become very natural that this secure device will connect to other secure devices and establish those secure links and segment by segment, and such that it can be not only it can scale, of course, and also it can make sure this process of having a very high secure and high trusted domain very automatic and not only bottleneck to the controller only. So, this is the current NASR architecture, but I don't want to spend too much time in here. But basically, this is a 2-step or 3-step process. To prepare, like we said, the clients must state what kind of security properties he wants, and then the controller currently they kind of collect these properties, attestation results, or evidences, or pure measurements, from the network elements. But in here, this centralized source routing path could be like decentralized path computation, establishment, cross evaluation, and cross attestation, so on and so forth. And the rest will, be the same. Yeah, thanks. I hope I make myself clear. Any questions or comments?
Yeah, thank you very much, Peter. I'll hold back. Anybody else have questions?
Yeah, Peter. As I already commented earlier by email, actually, because the NASA and SRE seems bigger than what you would like to put in the ANIMA working group. So I guess we will wait to see what the main part of NASR, whether you are going to create because obviously that's belong to the routing area, right? So we think only after the main parts of the NASR are decided, then we can see whether that's the operational and management solutions fit into ANIMA or not, right?
Yes, thank you, Shem. Yes, exactly. We still don't know the outcome of the NASR initiative because we're having this BOF and we don't know the outcome. But logically speaking, being one of the proponents, like NASR will shorten the scope, and because it's right now currently placed in a security area, the team, the participants in the NASR mailing list have the interim, the biweekly call, and decided that routing might be something in the solution, but not in the NASR working group. So yes, you're right. This might be like NASR is a big thing that appears to be a big thing, but in the IETF way of speaking, it will focus on very small and narrow, work for just attesting the path, and the path computation and how to create those trusted paths is currently out of scope. Is considered a input of the NASR architecture. So this will be done somewhere else in routing or ANIMA or other working groups.
Mm-hmm. Yeah.
But you're right, we still don't know the outcome. Yep.
Hi, Peter. You mentioned one goal is to avoid the bottleneck of centralized path computing. So is this specific to NASR scenario, or is just a general problem for centralized for the bottleneck of centralized computing? So NASR requires clearly more computing resources than normal path computing.
Not necessarily.
Sorry, Michael, you want to add?
Oh, I was going to say not necessarily. I mean, it could be more or less. It could be that you get to ignore a bunch of possibilities because you don't trust them. So that reduces your set. of possible systems, right? So I don't think that my guess is that, you know, it takes 4.5% more power, compute power, but I don't think it'll be a big change. Not like they're going to have to need another PCE or something.
Okay, thanks.
Yeah. It's not. Yeah, it's not going to be crazy. And also, if it's outside of NASA framework, if we still, you know, even though NASA is not success, you know, and you also still want to do some kind of trust-aware routing or security-aware routing, you may, you know, also consider these are some use cases, just not NASA use cases, just kind of a secure, you know, or trust-aware routing, some kind of things.
Yeah. And maybe also remember that even if we forget the whole dependency problem of, you know, where do we actually get the routing that allows us to do interesting paths to use for NASA? So if we put that aside, if NASA doesn't already have all the necessary signaling protocols from RETs, for example, to do its job, then we would have a good suggestion to simply define the additional signal that you need on top of GRASP, because that is very nice framework that doesn't only give you, you know, secure point-to-point communication, but also the group communication because of the GRASP flooding and discovery mechanisms, right? So I think from that perspective, there are two possible avenues, right? Using ANIMA aspects, whether it's Brewski or GRASP, for signaling of NASA proper, just as tools that you can use. And the other one is to look at how ANIMA could help with the, you know, dependency of, you know, the routing that you need.
Yes. All right. Thanks.
All right.
Okay, I guess we're done today. We have very good use cases proposed today. Many of them, you know, we think could fit into the current ANIMA use case. Some of them we would consider it when we try to recharter with wider range. And we do encourage people to discuss it in the mailing list and you know, make more deep detail designs and also submit the draft to the ANIMA working group. Anything else, Terence?
Yeah, I think I would. I think we need to work a little bit on the notes. So I think we haven't gotten together all the possible drafts. I would like to add them. I think Michael was pointing to that so that we can make sure that the notes of the site meeting also serve as a good starting point for other people to read up on the individual topics beyond the presentations. So we'll take a little while to finish on the notes and update the slides on Data Tracker and try to add the pointers. And otherwise, there should hopefully for everybody who is at IETF 122 in person, a good opportunity to talk offline on the hallways or so to help you, you know, improve the proposals so that they're may become more practically focused in a way that the ops area does typically expect us to have them be.
Okay, see you guys in Bangkok, if possible. All right, thank you all.
Bye.
See you.
Thank you. Bye. See you in Bangkok.